is do the roots of complex numbers. So which is the backwards of multiplying, isn't it? So we're going to run all those multiply rules backwards. You know what I mean? Let me go here. Like, if you know that like 2 to the third power, 2 times 2 times 2 is 8. So vice versa, the cube root of 8 is 2, huh? Because it asks the question, what times itself 3 times will be 8? Well, 2, we just did it, right? So roots are multiplying backwards, aren't they? They ask what will multiply to be this thing. And remember the special rule we've learned about how you multiply complex numbers. If you have a complex number like, I don't know, let's say 2 cosine 120 plus I sine 120. Remember how they go, right? They have a number in the front, and then they have the cosine and the I sine of the same angle. Times, let's say you're multiplying by, well, let's just take it to the second power. Or third power. Let's do third power. So how would you do that to the third power? And let's make the angle simpler here. Instead of 120, let's just make it a nice even 30 degrees. So yeah, how would you do that to the third? What did we learn about when you multiply? You add the angles. You multiply the numbers in front, add the angles, huh? So if you did a power, right, that would mean this times itself a second time and a third time, right? So in other words, it'd be 2 to the third power, wouldn't it? Because it'd be 2 times 2 times 2 in the front. And then the angles would add 30 plus 30 plus 30, 90, huh? So in other words, the quick rule is you could just power the number in the front and then just multiply the angles. So power the number in the front and multiply the angles, right? That was de Moivre's theorem, the observation, which made things go quicker. So, yeah, so you just multiply the numbers in the front. I'm sorry, power the numbers in the front because it's 2 times 2 times 2. It's this, which is a power, right? And multiply the angles by 3, so you get 90. So that's great. That's perfect, great. Now let's think that backwards. That's what because today we're rooting. So now we're going to say, okay, well, if that's the case, if when you do a power, you power the number in the front and multiply the angles, then vice versa. Say I want to do the cube root of, let's say, 8 cosine 90 plus I sine 90. Yeah, let's do that backwards now. So now I suppose I want to do the cube root of that complex number. Well, you think, well, I just did it right here. I just took that and I did the third power, and it became that's your 8 right there, right? 2 to the third power. It just became that. So I know what the answer is. The answer is the cube root of 2. I'm sorry, the cube root of 8, which is 2. I think with me on this, right? You guys with me logically? Because the best thing is if you get it. Really in math science, it's always like get the idea. I mean, the specifics will come, but get the big idea, right? Couldn't you cube root this thing by just saying, well, look, it's just cube root of 8 is 2. And then what angles do you need to multiply by 3? Going to be 30, right? Plus I sine 30. That's got to be the answer, doesn't it? Because we know that if you take 2 cosine 30 plus I sine, that's a plus I sine 30 there, plus I sine 30, that if you did it third power, like we just did it right there, third power, it becomes the 8, 2 cubed is 8, 8 cos 90 I sine 90. Piece of cake. Well, not the whole story, though. You tracking with me? I'm going to do something. I'm going to show you why that's not the whole story. That's true, but also some other things are true. What do I mean? So you with me? If something here, let's go back one. How would you prove that the cube root of 8 is really 2? How would you show a young child that that's true? You'd go, well, look, 2 times 2 times 2 is 8, right? 2 to the third power is 8. So the cube root of 8 is 2. Right, perfect, great, totally true. So therefore, same thing with let's do the cube root of the complex number again. 8 cos 90 plus I sine 90, right? We would go, the answer is just 2. And cos of 30 plus I sine 30. And how would you prove that's really true, that that's really the cube root? You would say, look, if I took this thing and I did it to a third power, it would go back, right? Because you would third power the 2, 2 times 2 times 2 is 8, multiply the angles by 3, they'd go back to 90. True, but not the only truth, Here's what's also true. Observe with me. Not only is 30 degrees going to work, but let me see if I can figure it out. Always formula's hard for me too. So add 360. What you do is you add 360. Wait. No. You divide them both by 3. So that'd be 30 and add 120. 150. So 150 also works. It's not just 30 that works. 30 does work. That's true. 150 works. How do you know? Let's see it. If I'm saying that is an answer. Absolutely true. That's one of the answers. But there's actually 3. When you do a cube root, there's actually 3. Here's another answer. That I'm claiming that to the third power also goes back. Does it? Well, let's see. 2 to the third power, 2 times 2 times 2, 8. Yeah, of course, that's obvious. Okay, but what about the angle? What's 3 times 150? Remember, you multiply the angles? Well, it's 450. That didn't work. It's supposed to go back to 90. Wait, hold on. What is 450? Am I losing you? I don't want you to be lost. The punchline makes no sense if you don't understand the joke. The conclusion is not helpful if you don't get it. You tracking with me? I'm saying this is also a third root. And there's a third one. There's not just one. This one is true. That's one of them. But this one works too. Let's prove it. Third power, if that's really another answer, then the third power of that thing should go back, shouldn't it? Third power of the 2 times, that part's right. Yeah, that goes back to 8. Yeah, that's easy. But why 150? Well, 3 times 30 went back to 90, so that was good. What's 3 times 150? 450. Now, what's 450? What's 450 the same as? Yeah, if you subtract 360, because that's more than one whole rotation, guess what you get? 90. It is right. Do you see, that's a second answer. How am I getting that? That's the K thing. Like Marilyn was asking, like, what's the K thing? That was Marilyn, right? Yeah. What's the K thing? That's giving you the other answers. There's not just one answer. For a third root, there's 3 answers. For a fourth root, there's 4 answers. For a fifth root, there's 5 answers, etc. And how do you find them? The K thing. Now, I can tell you now, how did I come up with the 150? I was doing the K thing in my head, which was hard. I could barely do it. And there'd be a third answer. It's not just the 150. The other one would be, let me see, what did we add there? We added 120. Add another 120. 270. The other one would be 270. Cosine 270, right? Is that right? Yeah. Plus I sine 270. That one to the third power would also work. Third power 2 is 8 again. You know, that works. 270 times 3. I can prove it's true. Times 3 would be 0. It's at 21, 60, 810. Now, what's that? Subtract 360. Subtract 360. Guess what you get? 90. That one also works. Now, I'll show you how I'm finding those. But are you getting the idea? When you do a third root, you can't just simply root the number in the front and divide the power. That's the main idea. You with me? You're getting the main idea, right? To root things. So if one more time, if when we do a power, right here, when I do a power, when I do like a third power on something, I power the number and I multiply the angle. Then backwards, when I root something, I root the number and what? Divide the angle, don't I? By 3. Are you tracking with me? See how that's the reverse? The reverse of, roots are the opposite of powers, right? So powers power the number in the front, multiply the angle. Roots root the number in the front, divide the angle. 90 over 3 is 30. But that's not the only answer. There's other answers which you find with the K thing. Question, Austin? Oh, no. Good? And I'll show you how it all works.
Why is it 120 degrees?
Yeah, it's because both these guys divided by 4. Right? That 4 is under both. 4. Oh, why is it 120?
Yeah.
That's the original thing they gave you. That was the original problem.
Oh, okay.
I just gave you an example problem on that. Yeah. All right. So So let me give you the general game plan. How did I find the well? How do we do it? Let me write that example and talk you through it one more time. So how do you find, for example, the fourth root of, and I just made up a complex number, so this is just a complex number example. Okay, so there it is. The fourth root of 16 cos 120 plus I. So that's a complex number, right? has a real part and an imaginary part. The I is the imaginary part. Remember, that's how it's polar form of a complex number. That's how we learn to write. Polar form of a complex number. Now, how do you do the fourth root? I'm telling you there will be 4 answers. There's 4 answers. How do you find them? Well, the first thing you do is you say there's going to be a bunch of angles. How do you find the angles? Well, if you want a fourth root, in general, you've got to take 120 and divide by 4. Right? I mean, 30 degrees, right? Because that's so 30 degrees to the 4th power will go back to 120, won't it? Are you with me in the basic idea? Right? So to root, you got to divide the angles. But it's not just the 120. Any extra full rotations, that's what the 360K is. So let me just get rid of the K for a minute, and I'll bring the K in a second. If you, not only 120 divided by 4, but 120 plus a full rotation, because that's still 120. That's still the same place on the unit circle, right? If you say, well, here I'm at 120, there's 120, right? Just a little past 90. I'm at 120, or I'm at 120 plus a rotation. Well, same spot, right? So if I go, well, 120 plus a rotation, that will also work because it's the same spot. So in other words, that's how you find the extra answers. So in other words, what is that? That would be 480 divided by 4. That's 120 degrees, right? Yeah, that's 120 will also work just like 30 will. All right, I better just move forward at this point with the game plan. Not just one. So let me just give you the steps. So at this point, it's enough theory. You need to see it, I think. So it's K here. And why it's K is because it's not just one rotation, but 2 or 3 or 4. As many extra rotations as you want. Same spot, same spot, same spot, same spot. Go around as many extra times as you want. You're at the same spot. So that's the deal. So now how do you simplify that? Divide them both by 4. That becomes 30 plus 90K, right? It's divided him by 4 and divided him by 4. So that's what you do. When somebody gives you a fourth root, you take the angle they gave you, you put it right there, you go plus 360K every time, because extra rotations, divide the whole thing by the root number, you get that formula, and then you plug in K equals 0, K equals 1, K equals 2, K equals 3. How do I know to stop there? Because for a fourth root, there's going to be 4 answers. So it starts at 0, so 0 through 3. And then you just plug in the K here every time. So plug in 0, 30 degrees plus 90 degrees times 0. That's just going to be 30 is our first angle. And then 30 degrees plus 90 degrees times 1, which is 120. And 30 degrees plus 90 degrees times 2, 180 and 30, 210. And 30 degrees plus 90 degrees times 3 to 300. That's our 30. So all those angles, any of those angles times 4 will go back to be 120. That's what we just figured out. Any of those angles times 4 will go back to be 120 is what it is. So what are my final answers then for the whole problem? The final answers, the 4 complex numbers who are roots of, or who are fourth roots of that original, is the fourth root of 16. I forgot to do the number. Fourth root of 16 is just 2. So it's going to be 2. They're all going to have 2 in the front. Cosine of 30 plus I sine 30. And 2 cosine of 120. It's just those angles. We just do those 4 angles now. They're all the same setup with the 2 in the front. And 2 cosine 210 plus I sine 210 and 2 cosine 300 plus I sine 300. There they are, the 4 answers. So that's how we're going to do it every time. All right, let's do the actual first question here. So number 18 is saying, find all complex roots, square roots of that. Okay. All square roots of 81 cosine, and the angle is 60 degrees. So there it is. There's our problem. Square roots. What does square roots mean? Two roots. They want me to find all two roots. Square is 2. Cube is 3, right? So find all square roots of that complex number. How do we do it? Well, first off, let's do the angles. So you write your angles. And what are your angles going to be? You take the angle they gave you, the starting angle they gave you, 60 degrees. Yeah, we're going to divide the whole thing by 2 because it's square root. But you got to write plus 360K. So you take the angle they gave you, plus 360K, divide the whole thing by 2, because, square roots divide angles by 2. Right? And then simplify that, divide them both by 2, we get 30 degrees plus 180K. Is that good? I just divided both of them by 2. And now, I'm going to do the different angles. So then you go K equals 0. It's going to be 30 degrees plus 180 degrees times 0. It's 30. Keep going. How many answers are we going to have to this problem? 2. You're just going to do K equals 0, K equals 1, and done, huh? Going to have 2 answers for a square root. So it's going to be 210. So my 2 angles are 30 and 210. All right, so now we can go to the overall answers. What are the answers to the problem? So how do we write? What do we put in the front? What's the number in the front going to be?
9.
Good, because it's the square root of 81, right? It's the 2 root of 81, which is 9. Yeah. So the answers are going to be 9 cosine, and you do the first angle, 30 degrees. 30 degrees plus I sine 30 degrees. And the second one's going to be 9 cosine 210 degrees. Plus I sine 210 degrees. Done. Now, I think done. Maybe they want, what do they want? Yeah, that's done. That's all they want. They want it in that form. Exactly, done. In a minute, they're going to make us go all the way back to multiply those out and get the real number, measuring number format, what's it called, rectangular, regular. That's polar form. They're letting us stop here at polar form on this problem. Did that make sense? What we're saying when we're saying these are answers is we're saying if you took either one of these to the second power, it would go back. Because these are both, just like, if I said 9, the square root of 81 is 9, because if I took 9 to the second power, it would go back to 81, huh? Right? Likewise, that's what we're saying about these complex numbers. We're saying if I took this complex number to the second power, it would go back to this. Would it? Look with me for a second. This is the part where I try to sink it, make more sense. I understand you can do the steps. It's even better if it makes sense. If I took this to the second power, what would happen? You would second power the 9, 81. Good, that's all good. And what would you do with the angles? You power the numbers in the front, you multiply the angles, right? 2 times 30, 2 times 30, 60, 60. Great. Yeah, that's the obvious one. But how about this one? Does this one work too? If I took this one to the second power, would it also work? It would. Second power of the 9, 81. No big surprise there. And multiply 2 times 210. What you going to get? 420. Subtract, because that's more than a whole rotation, right? So to find out where it is, subtract whole rotation. Guess what you get? 60. See, that is 60. It works. It goes back, huh? That is another square root because second power does go back, doesn't it? Those are the two places that are square roots. Good? It's making sense? This little method's helping us find that. How'd we find it? Because we added the extra rotation right there, the 360K. That's what gave it to us. Be 3 answers to this question, huh? 3 answers. So let's see what you can do. Doing good. All right, so let's find our angles. So the angles are, to find these angles, we've got to take the 2, you always take the one they gave you, and you go plus 360K for the extra rotations, divide by the number, the root number, the 3. Is that making sense? The angle they gave you plus 360K divided by the 3. And then just divide the 3 into both those. You'll get, what is that, 80 plus 120K. So there we go. Now let's crank them out. So for K equals 0. So K equals 0. It's going to be 80 degrees. Plus 120, 0 is 80. K equals 1. What's that? 200. And K equals 2. 240. What's that? 320. So there we go. So there's our 3 angles. Okay, good. So now you can write out the 3 answers. It's just going to use this. Oh, I forgot the root thing. It's cube root of, yeah, did you do that in your calculator? The cube root. You know, you probably have a cube root button. Do you know where that is?
No. It's shift and then the root button.
Well, yeah, it depends on the calculators. Yeah, on the little Casio one.
Natural display.
Shift in the root. Yeah. Now, if you're not sure, you can just guess. I mean, it's not going to take that long. It'll just take like 4 times 4 times 4. No, it's too small. 5 times 5 times 5. Yep, got it. So you could just guess if you can't find that cube root button. So plus we're going to have 4th roots and 5th roots in a minute. And you don't have one of them buttons. Well, actually, you do have a special thing that'll do it. I could show you, but they're all different. So I'd have to show you individually. Anyway, I would just guess. I really think the quickest thing is just guessing. I know that sounds funny to say in a math class, but I would guess. Because just take you a second. Just go 7, 7, 7. No, oh, it's too big. 6, 6, 6, too big. 5, 5, 5. Oh, got it. Just take you a second. All right, so 5 is it. So let's crank them out. Here we go. So it's going to be the answers. How many answers?
3.
Yeah, cube root, 3 answers. So it's going to be 5 cosine. Then you just do the angle sign. Here comes the 80 first. Cosine 80 plus I sine 80. Next comes 5 cosine 200 plus I sine 200. And then 5 cosine 320 plus I sine 320. There we are. Those are the 3 different cube roots. If you took any of those to the 3rd power, the angles would all go back to 240. The second 2 with extra rotations. Good to there? All right. Give me that in, what's it called? Radian angles. So, yeah, I'd probably just leave it. I mean, you could change the degrees, but then they're going to make you change back in the end. I think that'd be more work. Let's just leave it in radians. Can you do it in radians? So first thing is to find the angles. So how do you find the angles? You start with the angle they gave you, which is 5 pi over 6. So start with the angle they gave you, 5 pi over 6. And instead of adding 360K, what am I going to add? What's the same as 360? 2 pi, huh? 2 pi K. Over what? 4, because that's the root number. See how that's the same thing? Instead of using 360K, we're using 2 pi K, because 2 pi is all the way around, just in radians, just like 360 is all the way around in degrees. Now, it's a little messy. Let me, we got fractions and stuff. How do you divide both those by 4? Well, the easy way is just multiply that by 4. Did you know that? 5 pi over 24. You can just do that like that. Plus, and then the 2 pi k over 4. That 2 goes into 4 2 times. So we get 5 pi over 24 plus pi k. How's that? Is that okay? Did everybody track with that, what I did there? Oh, you're right. What am I doing? Thank you. Pi k over 2. Pi over 2k. Thank you. You're right. I wrote it there and then didn't bring it over. Yeah, so we good? To there, does that make sense what I did? That 4, so when you're dividing by 4, to divide just means to hit the denominator like that. So I just hit that denominator. That is dividing. Whenever you multiply the denominator, you divide it, really, because you did the bottom. Does that make sense? That good? All right, so we get to there. So now, let's crank out our angles. So, what are our angles? Oh, wait, we got to do the k thing, huh? So we're going to start with k equals 0, and k equals 1, k equals 2, and k equals 3. So k equals 0. We take this right here. We're going to crank it out. So 5 pi over 24 plus pi times 0 over 2. And so that's just 5 pi over 24. We just get rid of that 0, just makes that second part vanish. Good so far. This is going to be a little messier. I need a little more space probably here. Next, k equals 1. 5 pi over 24 plus pi times 1 over 2. We good to there? I want you to see this part. What are we going to do to add those two together? Common denominator, huh? So going to have to multiply top and bottom by 12, right? So we will get 5 pi over 24 plus 12 pi over 24, 17 pi over 24. Is that good like that? Does that make sense? And then you just do 2 more of the same? Yeah.
So does the k just multiply to the pi?
Yeah, so the k is just on the pi there. So yeah, so when k is 1 or 2 or 3, I plugged it in right there. That's where the k number went. Yeah, because that's the only place the k is. Yeah, exactly. Is that good? Can you do k equals 2 and 3, right? Because we have 4 total, so 2 more, right? So do the same thing, common denominator, all that stuff. Yeah.
I have a question.
Kevin.
What's the cubed root, the fourth root of 64?
Yeah, so usually what I do is I'd use my calculator. So don't say it out loud. Give everybody a chance. Use your calculator. Just say, I don't know, maybe it's 3. 3 times 3 times 3 times 3. Just multiply that 4 times. See if that comes out 64. If not, go higher.
Yeah, I did that, but it's not even number. It
Oh, you're right. I forgot. I'm going to have to do that one. You're right. So I'll get to that one in just a minute. You're right, Kevin. I was thinking they were all whole numbers. They're not. You're totally right. Thanks. Yeah. Too long. Too late.
There you go.
Yes.
The one to show it in rectangular form, can you show us that too?
Oh, yeah. Do we? Okay. Yeah. Shoot. Okay. Yeah, we got work to do. All right. All right. Forget. These take forever, and the next two are even longer. All right. Let's get going. Okay. So k equals 2. So 5 pi over 24 plus pi times 2 over 2. Is everybody good there? See what I'm doing there? Now, what do you got to do to get common denominator? Same thing again, top and bottom by 12, huh? And so we get 5 pi over 24 plus what? 24 pi over 24 which is 29 pi over 24, our third angle. Good to there? And now our last angle, our fourth and last, k equals 3, 5 pi over 24 plus pi times 3 over 2. So see what I'm doing? I'm just doing pi times 0, 1, 2, and 3. That's the k. That's where the k plugs in, just like it shows right there. So that's where the k plugs in. Okay, so now same thing, common denominator, top and bottom by 12, yet again. Get 5 pi over 24 there, plus 36 pi over 24. What's that? 41 pi over 2. So there's our four angles. So let's go write the answers now. So it's going to be each of those. Oh yeah, but I got to do the fourth root thing, like Kevin was saying. Yeah, let's do that. So if you're okay with those four, can I go to a fresh screen? We need to do the fourth root of 64. So everybody got those down? That making sense? Kind of messy. All right, so fourth, how do we do the fourth root of 64? Yeah, Kevin's right, this one's not clean. So what I do is I break it down. So what times what, 64? You use your calculator. You might remember 8 times 8, 64. You could do 2 times 30, whatever, just whatever you want to do. 2 times 4, 2, 2. Break down the 8. 2 times 4, 2, 2. So what do you have all together then for that fourth root of 64? We have fourth root of, and 2, 2, 2, 2, 2, 2. 6 twos, right? 1, 2, 3, 4, 5, 6. That's the guts of a 64. That's what's in a 64. Now, remember how roots work from your algebra days?
Yeah, you take out
Yeah.
one of them.
Yeah, whatever the 4 in the hook means, it's a 4-for-1 deal. So 4 twos ship 1 2 out, and they're gone. So 1 2 on the outside. What's left on the inside? The other 2 twos. 2 times 2, 4. So it's 2 4 through to 4. So I thought they were going to come out nice, clean, whole numbers. They do not. I forgot how messy they make this section. So 2 4 through to 4 is the best we can do. Now that's going to be the front, and now I just write those four angles. Cosine of the angle plus I sine of the angle. So here we go. So the answers are, so 2, 4 through to 4, cosine, I'm going to write this 4 times. 2, 4 through to 4, 2, 4 through to 4, 2, 4 through to 4, cosine, cosine, cosine of some angle, plus I sine of the same angle, plus I sine, plus I sine, plus I sine of the same angle. And what's that angle? Well, the first one was 5 pi over 4. So let me write those in. So 5 pi over 4, is that right? And then 17, 1729, so...
Wasn't it 5 pi over 24?
Oh, is it? Oh, 24, you're right, you're right. (29 pi over 24). And then, so it's going up by 12. Notice there's a pattern. It adds 12 every time to the top. There's always a pattern in these. Adds 12, adds 12, adds 12 would be 39. 41, was it 41? Yep, 41. 41 pi over 24. 41 pi. That's math. Math is just all patterns. Okay, so so there we go. So there now they want rectangular. You're saying? Is that what you said?
Yes.
So they don't let me stop here. Really?
No.
Yeah, you're right. This is terrible. Okay, and this isn't, and it gets worse. Yeah. So now we can't. That's so far so good, but still not done. Now we have to actually use our calculator, find out what all these are, and multiply them. Do they want exact? What do they want? Decimal? Oh yeah, round to the 10th. So they just want rounding. Yeah. So now you just use your calculator. I'm going to rewrite these. So 2 4th root of 4 times, and then cosine 5 pi over 24 plus I sine 5 pi over 24. So I would just simply use my calculator. Now that's not easy to do. Can you get that in your calculator? 4 through to 4? Oh yeah, you might not know how to do that. Here, since they want me to since they're not letting me stop here, if they let me stop here, I'd be done. I'm going to go back to the way it was originally. It's going to be easier. What was it? 4th root of 64. Just use that. Now, let me show you how to get that. Are y'all with me this morning? Y'all have your calculator ready? Or whatever calculator you have? Show you how to do the 4th root of 64. That is 64. Now, there's different ways. You might have I don't know what you have, and that's what's hard. Every calculator is a little different. What's that? You're right, the up arrow. I'm with you. Yeah, the caret. It is called a caret. You're right on. So I can show you that way. Is that what most of you, or some of you will have an X root of Y button. Do you have that? You can just do it that way. You can just do 4th root of 64. If you have that button. If you have the X root of Y button, just do that. If you don't, if you have the caret, the up arrow, just go to the 1/4 power. I don't know if you remember from algebra, what fractional powers are the same as roots. A 1/4 power is the same as a 4th root. Either one of those will work. So let me write that over here on the side. So the 4th root of 64, or 64 to the 1/4 power. Either one of those will give you the same answer, which is 2.82, blah, 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 blah. You getting that? Okay. No? No, you did the square root of 64. No. Or what did you do? I don't know.
64 divided by 4.
How many places do I want us to round to here? 1. So I'm going to go like 3. What's that?
What do we do?
64 to the 1/4.
Just divided it by 4, I think.
Oh, yeah, probably just divided it by 4. Did you do the up arrow to the power?
Yeah.
Oh, you didn't put parentheses around the 1/4.
No.
Right. So it only did the 1 power and then divided by 4. Yeah, do the parentheses. So I've got parentheses here.
Yeah.
Okay. We good? We getting that? So you can either do the 4th. So everybody got that? Let me make sure I can help with this. So just put that in the front. And I went 3 places because I looked at the final answer. They want 1 place. So always use a couple more spots, right, when you're in the middle of a problem. So I'm just going to use 2.828. And then I'm going to multiply boom, boom. And what do we get? So I'm going to take that 2.828 times. Oh, make sure you're in, what mode you got to be in? Radians. Times cosine. If I got to use your pi button, I'm getting, so I did the first multiplication. I got 2.2 plus I, and then I'll take 0.828 times sine of 5 pi over 24, and I'm getting 1.7. There's the first of 4 answers. Did you get that? So let me go around a long time. I got to do 2 more that are longer, and we got to start the next section. So let me whip these out. Whip these out here. So cosine, and the second angle is 17 pi over 24, right? 17 pi over 24 plus I sine 17 pi over 24. So again, just hit the buttons on your calculator. So 2.828 times cosine of 17 pi over 20. You don't need to do the closing parentheses. I don't know if you know that. You never need to close parentheses. Yeah, so you're right. I got what you guys are saying. Negative 1.7 for the first part, and 2.8 times sine 5 pi over 24. I'm getting plus 1.7 I. Second answer. Did you get that okay? Then I'll go on to the third answer. 2.828 cosine, what is it, 29 pi over 24 plus I sine 29 pi over 24. So then I'll do that one, 2.828 times.
I got something else for the second part of the
The
previous
second
one.
and third, I got negative 2.8.
Did you? Oh, I typed in the wrong one. Ugh. This is tedious, isn't it? Yeah, I did the wrong. 2.2? Yep, I messed up. Thanks. 2.2. All right, and then. Did you get that third one? Same as me? And then the last one. What is it, 29 and 41? And times cosine 41 pi divided by 24. I'm getting 1.7 again. And 2.828 times sine 41 pi divided by 24 minus 2.2i. Whew, there they are. 4 answers, 4 screens. Those are the fourth roots of that original complex number. Are we okay there? Want to write all those down? You got them? Do you guys get them on the calculator? All right, I better move on. Huh? They just give us a straight number, 100,000. I mean, there's no angles. What's up with that?
This is a trap.
It's a trap. It's a trap. Avoid it at all costs. So they want the fifth roots of 100,000. So you know what the first step is now? Here's the plan. And it's a long, terrible plan. Step 1, change to polar. You see, you have to have angles. You've got to have this whole de Moivre theorem is got to be in polar form. So change to polar. Find the 5 roots. Change back to regular, or rectangular as they call it. Yeah, you see, now it's regular to polar, back to regular at the end. Plus, in the middle, we got to do the whole 5 roots thing. This is like a half an hour problem, probably. We don't got a half an hour to give it. I know. All right.
On the answers that they give, they're all different, right? So if we find like the first 2 or 3 of them, then we should be able to get the answer.
I don't know. We'll see. Yeah, they're symmetric. If I had time to show you, they're symmetric on the complex plane, is what they are. It's very interesting, this whole... Yeah. It breaks up the unit circle into nice little... Yeah, so if we get it, maybe I'll take time. There's always a matter of time. All right, so let's go. First off, change to polar. How do you take just like a plain old number, 100,000, and change it to polar? What do you do? Let's graph it on the complex plane. Remember, this is the imaginary axis. And this is the real. Remember the complex plane? If somebody gave me something like 3 plus 2i, where would that dot be? Right 3 up 2, boom. That would be the dot 3 plus 2i. Remember how the complex plane works? Right? So the real numbers go sideways, and the imaginary part go up and down. So you would go right 1, 2, 3, up 1, 2, huh? Okay, so what's this then? Pure real. So in other words, plus 0i, if that helps. It's all real. Okay, great. So where is it? It's way, way, way out here. I don't have room. But it's way out there at 100,000 plus 0i. It's not up at all, right? Because it's got no imaginary component. It's pure real. 100,000 to the right plus 0i, isn't it?
So with
Okay, so now I want to change that. Change it to what? To polar. And what does that mean, polar? You need an r. How do you find the r? The length.
the fifth root of
Oh, you guys are getting confused. It's the hypotenuse. Remember, if you wanted to find the length of this one, it'd be a right triangle, right 3 up to square root of 3 squared plus 2 squared. Remember that? So for r's, it's the square root of a squared plus b squared. Remember that formula? That's how you find the length of a. It's just like the magnitude of a vector. They're basically vectors, right? Too much math, all kind of together. So the length of these vectors, it's not really a vector. The length to the complex number, same thing as a vector though, is hypotenuse of a right triangle. Square root of a squared plus square root of what's a? 100,000. That's a. B's the 0. The real a and b are the real part and the imaginary part. 100,000 squared plus 0 squared. Well, that's the square root of 100,000 squared. The 0 does nothing. Guess what that is? Yeah, it's 100,000. Obviously, how far out to this vector? Well, it's 100,000 straight to the right. That'd be 100,000. Right? Understanding is always better than formulas. If you really get it, if you really understand what the question is, how far out to that vector, it's like 100,000, obviously. Right? And now what's the angle? Now, rather than write a formula, tangent inverse, blah, 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 understanding is better. You tell me, what angle is that?
would it either be 0 or 360?
Eggs, 0. Yeah, that's at 0 degrees. It's straight right. Straight right. 0. Right? That makes sense? Now, you can do the formula, tangent inverse, remember the positive b over the positive a, all that stuff. You know, you'd get 0.
0 over number is 2,000.
Yeah. You'd come out 0. So, but that vector is, the vector straight to the right, that's at 0 degrees, huh? That's not up at all. Let me get rid of this vector. Right? You know what I mean? That vector's straight to the right, so it's not up at all. It's at 0 degrees.
Is that considered a segment?
It's a line segment from geometry. That'd be a line segment. Yeah.
So when we do it in the fifth root form, it would look like the fifth root of 100,000 cosine 0 plus
Yeah.
cosine 0.
Yeah, so the number is 100,000. Because remember, you put the magnitude. Remember how this works. You put the r in the front times the cosine of 0 degrees plus I sine 0 degrees. Remember how you write them as polar form? You always put the r in the front. You always put r cosine of the angle plus I sine of the angle. So I did that. There's the r. The angle is 0 degrees. This is a fancy way to say 100,000. Is it? What's the cosine of 0?
1.
1. So 100,000 times 1. It's 100,000. And what's the sine of 0? 0. This vanishes. Bye-bye. It's just 100,000 times 1. It's 100,000. It's a fancy way to say 100,000, isn't it? In polar form. We good? That's step 1. So we've got polar form now. We changed it from normal to polar. So now we say, okay, they want the fifth root of 100,000 times cosine 0 degrees plus I sine 0 degrees. Fifth root of that. All right, you know the process.
When you do the angles thing, it's just
So what do? We take 0 plus 360k over
divided by
5. Huh? Remember the game plan? You take the angle you're starting with plus 360k divided by 5. Maybe we should just always work in degrees. That was kind of a pain doing radians.
I was gonna ask that. Do you have
Yeah.
to do it in degrees, or can you convert
Certainly on the last one, since the final answer
it in radians?
was
Or
just
decimal?
numbers.
Okay.
Yeah, then who cared? They didn't know what we did in between. Yeah, so we really should have just done that one with degrees. That would have been easier. The only reason I stayed with radians is I thought they were going to make us give a radian answer at the end. I didn't realize we were going to go all the way past it and just give numbers. Yeah, so if you see that in the end they just want numbers, I would just do degrees in the middle because that's easier than radians. But if they want a radian answer in the end, if they want a polar form answer in radian, then probably easier to stay with radian. You could do either one. I'm just suggesting what might be easier. So, good so far? So this is going to be what? 0 over 5 plus 360k over 5. And what's 0 over 5? 0. And 360, isn't that 72? Yeah, 72 degrees times k. So 0 plus 72 is just 72k, huh? 72k. We don't even need the 0. What is the 0 adding to it? Nothing. So 72k. So there's the plan. So start with k equals 0. Get 72 times 0, which is 0. 0 degrees. Do k equals 1. 72 times 1, which is 72. K equals 2. 72 times 2, 144. K equals 3, 72 times 3, 210 and 6, 216. How many of these we got to do? 5. For fifth roots, you're going to have 5 of them. Right now I've got 4. One more. 72 times 4, 288 degrees. There's the angles. Yeah, if real quick, like Chanel was saying, if you break this up around the unit circle, it's symmetric perfectly. 72 degrees is about right there, and then 144 is right there. 216 is
Make an X.
right there. Does it make an X?
No.
And then 0's right here. Here's 0, 72 degrees, 144 degrees, 216 degrees, and 288 degrees. It perfectly breaks up. They're exactly symmetric as they go around the unit circle. There's where our 5 complex numbers are going to end up perfectly. They always perfectly symmetrically break up the complex plane. It's interesting. It's a whole very interesting area. They have some lot of neat stuff which we don't have time for. All right, so let's keep going. So we got our angles. 1, 2, 3, 4, 5. So now we can write out our answers. But first we got to start with the fifth root of 100,000. Did y'all get that? Yeah, 100,000 to the 1/5 power or fifth root. Fifth root of 100,000, however you did that. Fifth root of 100,000, 1/5 power. It comes out 10, doesn't it? 10 times 10 times 10 times 10 times 10, 5 times is 100,000. Obviously, there's 5 zeros. Every time you multiply by 10, you put a 0 on there, huh? So 10 to this, so it's 10. So the fifth root is a nice clean 10, so that's nice. Got a nice number out there. So let's write down our answers now. We able to do that? They're all going to have a 10 in the front, and then cosine plus I sine, and the angles will be those 5 angles. Yeah, but they're not going to let us stop there, are they? No, we have to go on and do the calculator thing. So here we go. So the answers all have a 10 in the front. Cosine, 10 cosine, 10 cosine, 10 cosine, 10 cosine, plus I sine, plus I sine, plus I sine, plus I sine, plus I sine. And the angles are 0, 72, 144. 0, 72, 144. and 216, 288. All right, and then hit the buttons on your calculator. Can I skip that step and just go, here's the answers. There they are. Oh wait, I don't even know which one that's right. Maybe I better do one. Is it D? So the answers are right here. 10 plus 0i, 3.1 plus 10 plus 0i. So 10 plus 0i, 3.1 plus 9.5. Negative 8.1, 5.9. Negative 8.1, negative 5.9. Yeah, you guys are right. It's kind of the same numbers back and forth with different signs, huh? 3.1 minus 9.5. There they are. They're all symmetric around the unit circle, around the complex plane. Okay, are we good with that question? Did that make sense? That was a pretty tricky one. Let's do one more of those. That's all we're going to have time for. We got to get on to other things. We got to start 5-3. So, we okay with that? So in the beginning, the part we had to do in the beginning is we had to go from the real number, the regular, to polar form, huh? And so the way to do that, remember, is the r equals square root of a squared plus b squared, and the theta tangent inverse. So let's cubits of -1. And they want, final rectangular form. Let me lay out the plan first. What's the plan? Step 1. Change to polar. Find the third roots and change to regular or rectangular, as they call it. Yep, there's the plan. And what I would do is I would take that -1 and make it say it's just pure real, huh? -1 plus 0i. Is that good? Make it a complex number. It's got a real part and an imaginary part. So if the imaginary part's missing, it's 0i. Then how do you change? What's the game plan for changing? So step 1, change to polar. How do you change to polar? R equals square root of a squared plus b squared. And then how do you find theta? Tangent inverse of what? The positive y over the positive x, huh? Or whatever you want to call them.
This is another 0.
The I over the real. No? This one's tricky. This is a little more, this is really important, guys, especially the beginning part. Positive I over positive real. But that's only a reference, remember? That's only reference. Draw the vector. It's not really a vector. Draw the complex number. Or graph it. This is one that's gotten people on exams in the past. Graph the complex number. Change the angle. All right. Nothing else will work. So the r, square root of a squared plus b squared. So that's going to be the square root. This is a and b, right? A and b are the real and the imaginary parts. So -1 squared plus 0 squared. Whoops, I'm being kind of scribbly here. Come on. Square root of -1 squared plus 0 squared, which is square root of 1, which is 1. Good? So the r is 1. The reference angle theta, if you do inverse tangent of the I over the real, it's always the Y over the X. So this is the Y, this is the X, but make them both positive. 0 over positive 1. But that's still just going to come out 0 degrees, right, when you hit the buttons on your calculator. But remember now, that's only the reference angle. You've got to draw it to actually see it. Now, to make that clear, I want to do all I can to make this as clear as possible. Think with me for a second. What if I got a reference angle of like 30 degrees? Okay? You guys all with me? And so pay attention to this part. This is super important. This tripped up like 3/4 of the class. I think it was this last summer when I taught it on this one. There was one just like this on the test. And they all said, the reference angle is 0. It's 0. And then the rest of the problems is wrong. You know? And so let me help with that. I know this is tricky for people, but think, to make it more simple, think what you would do if you got 30, okay? You wouldn't immediately say the answer is 30, you would draw it, right? Remember, that's what we've always done. That isn't something new. We've always done that. I've always said, when you do that inverse tangent thing, you got to make both these positive, and that answer you get is just a reference. You've got to find where you got to draw it to see where it actually is. And so if it said 30 and it was over, like, say here, let's say we drew it. Now I'm making up a different problem to give you insight into our problem. So if it was 30 degrees reference, what does reference mean? How far to the nearest? Oh, that word's important. Let that word sink in. Closest, nearest x-axis. There's two. There's an x-axis that goes negative. There's an x-axis that goes positive. There's two sides to the x-axis. This one is closest to the negative x-axis, huh? So if we got a 30-degree angle, 30-degree reference angle, that means it's 30 degrees with reference to the nearest x-axis. 30 degrees off that x-axis. It's not over here, 30 off this x-axis, is it? If we drew it, I'm saying if I drew it, if I actually graphed it, and I found that it was over here, then whatever angle I'm getting is from that x-axis, huh? So it's 30 off that. So what would be the actual angle from 0 then? It'd be 150 in that case, wouldn't it? Because in the end, we have to give the actual angle, which means from 0. The reference just tells us from the nearest x-axis. Okay, so what did we get in this problem? Well, we got 0. Right, but 0 can mean two different things, depending on which x-axis you're nearest. So graph it. Let's actually graph this thing. So how do we actually graph this thing? It is, where is it? Oh, here it is. -1 plus 0i. So it's back 1, up 0. It's right there, huh? Does that make sense? It's back 1, up 0. Back 1, up 0. So it's right there. So what is that angle? That's 180 degrees. Well, why'd we get 0 then? It's 0 off of this x-axis. It's 0 off the nearest x-axis. It's right on the negative side of the x-axis, huh? So the actual angle, though, from 0 degrees is 180. So that's our angle. It's 180. It's not 0. That's the actual angle. Does that make sense? So again, whenever you get your angle at first, you remember it can mean two different places. Well, it can mean actually 4 different places. You have to see, you got to draw it. You got to draw it. So ours is right there. So that's 180. All right, so now we can do it. So theta is 180 degrees. So we got our angle. All right, so now we can dive forward with the rest of the problem. Remember how to write the polar form of the thing? It's always r on the outside, cosine of the angle, plus I sine of the angle, polar form. So the r is 1. Cosine of 180 plus I sine of 180. Like that. And then, and then we do the thing from there. So that's all step 1. We changed to polar. We got our polar form of the answer. So step 1, it is, what is it again? 1 cos 180 plus I sine 180. like that. And then now we do our root thing. What root do we do? I don't even remember what root we're doing. Cube root. Cube root. We're supposed to do the third root. So, third root of that thing. Third root.
And the one part would just stay a one.
Yeah, the 1's nice. Third root of 1's 1. So that's nice. Yeah. And so what do we do for our angles?
Divided by 3.
Yeah, you take the 180 and you add 360K and divide by 3, huh? Remember how that works? You see, yeah, so that's why the angle's so important to get right, because we use it again and again. So divide them both by, divide by 3 and divide by 3. What's that be? 60 plus 120K. And so then we just go down the line. K equals 0. So we get 60 plus 120 times 0. K equals 1. 60 plus 120 times 1 is 180. And K equals 2. 60 plus 120 times 2 is 240, 300. I still do the same thing. Like that. And then we can write our 3 answers. So the 3 answers are going to be 1, cosine 1, cosine 1. Cosine and the angles are going to be 60 degrees plus I sine 60 and 180 plus I sine 180, 300 plus I sine 300. Is that good? It's getting more comfortable? This whole big messy process? It's painful, isn't it? There's only going to be like 7 or 8 of these on the next exam. I'm just kidding. There'll be like 1 that goes like all this way, and then parts of other things.
How long do we have to take the next exam?
7 hours. No, I'm just kidding.
6.
I think there's only 20. Well, there's always 20 questions, huh? Yeah, so, same time.
But this one's comprehensive?
Oh, no, the next one's just the 5th.
Oh.
And then we have the comprehensive.
Oh.
Okay, so then how about I just skip to the end here? They don't tell me the answers. I don't know what everybody got those? There's the 3 answers. That is a crazy long problem. That's a crazy long set.